Welcome to this afternoon's Tech Talk session. We're going to be focusing on some enhanced assembly productivity tools that's going to be coming out in Solid Edge 2021 here within the next few weeks. So I hope today you guys are able to glean some new information on some things that are happening within the mechanical side of Solid Edge, specifically here in the assembly environment. So from a Siemens perspective, we talk a lot about how our customers are harnessing the power of digital technologies and the digital twin to transform their businesses. And today, more than ever before, we see that the worlds of design and manufacturing and optimization are collapsing and pulling together more tightly. And the value of that digital twin lies really in how closely those virtual and physical worlds meet. And you have to think of the digital twin not just as the CAD digital twin, but also as the manufacturing digital twin, in which you can take the data from the field in a tight closed loop and then bring it back to design and manufacture to make products better. And then from a Siemens perspective also, we talk a lot also about the Solid Edge portfolio, and it's really very important to understand that Solid Edge is so much more than just the CAD system. And today we're going to focus on some of the new enhancements in the mechanical design space on the left, specifically assembly productivity. And while it's understood that Solid Edge is the best mechanical design tool in the marketplace, we want our customers to know that we have many great tools in these other areas within the Solid Edge portfolio. As far as the agenda for today is concerned, Eli is going to start off. He's going to do a quick introduction on why productivity matters, and then he's going to go into some of the specifics within the assembly environment, some new enhancements that are made to help that productivity. And then I'm going to wrap up towards the end with some additional tools, specifically within the frames and integration within our supplier catalog. So with that, I'm going to go ahead and turn it over to Ilya to get us started. As if you guys have questions along the way, feel free to type those in. We'll try to answer as many of those today as we can. And then if we can't get to some, we will try to respond back when we get that opportunity. So Ilya, take it away.
Thanks, Kevin. Hello, everyone. I'm going to start my portion of the presentation with talking about productivity. Why does it matter to the companies? Today, as you probably know, there is no shortage of challenges facing engineers. And it's understandable because schedules are getting shorter, budgets are drying up, the products are getting more and more complex, and not only in the number of parts, but also, which is, by the way, is growing exponentially, but also in complexity of different additional disciplines required to design this competitive product. Especially digital twin strategy heavily depends on accurate detailed representation of the product because, as we say, we need to have exact replica of a real product in order to successfully estimate reliability, functionality, and all that stuff. So Solid Edge constantly keeps improving its usability because we definitely need to meet the market's demands. And specifically, we're going to be talking about a boost of productivity that is available in Solid Edge when it comes to assemblies and large assemblies. So that's why we feel that productivity really matters, and specifically today we're going to be covering assembly productivities. And with a heavy focus on, of course, what's new coming in Solid Edge 2021. So first topic we're going to discuss is locate on inactive parts. What is it? It's simply ability to perform multiple operations on assembly and large assembly, including that doesn't have all the parts active. In the past, it was a problem, or I shouldn't say problem, but inconvenience, and performance was suffering because of that when we're talking about humongous assemblies. With Solid Edge 2021, elements can be located on inactive parts. So it improves assembly performance throughout the cycle of designing the product. It improves usability, reduces number of active parts. It goes easier on your systems, and and behavior of the parts still remain the same. This is very important to understand. So the way to enable this, you can do it in a couple different ways. First way would be to go through assembly portion of settings where you can turn on locate elements on inactive parts. And the second method would be to just enable it in a pull down under activate, inactivate parts. So having said that, we're heavily dependent on active parts, and this is first step, and we're going to be improving on this. But for now, we can perform on inactive components of the assembly. We can perform multiple different operations. We can do assembly relationship, motors, measurements. We can recognize key points, PMI dimensions, and so on. You can read for yourself. You can notice that there are a couple asterisks there displaying that there are some limitations we're going to talk about today, though. This is the future, the function that will be supported with inactive parts in the future, not as of SADH 2021. So as you can see, again, you can read this list for yourself. I'm not going to dwell on that, but just to couple important topics: that simulation is going to be available, 2D sketches, 3D sketches, frame designs, and synchronous selection manager, hole recognition. All that is very important, and it's coming in the future. So let's take a look at the product. Actually, I have this assembly open, and as I mentioned, the way to activate this option, you go to settings, options, and under assembly tab of the app options, you can see, if you scroll down toward the bottom, you'll see locate elements in inactive parts. So this is where you can permanently enable for your SADH. And the second way would be to enable it under this pull down, locate inactive parts. So I open this assembly. Let's inactivate all the components. We can easily do that. Just select top assembly and say inactivate. All the components, all the components and the sub-assemblies, they will become inactive. And you can see that those gray glyphs, they show in the assembly navigator that those parts are inactive, all parts in this assembly. And yet we can still locate components, and we can do multiple things of those components. First of all, if you want to use, let's say, look at face, that's a very convenient command that allows you to manipulate assembly's views. And you can easily select, let's say, this plane, and even though components are inactive, it's still available. You can perform measurements. For instance, if I want to measure distance between different holes or faces, I can easily do that. And you can see that system allows me to do that even though all these components are inactive. If you remember, there was asterisk next to measurements. And the reason for that was that when you do measurements with this particular tool, you're not going to be able to get centers of those cylindrical faces. But if you go to this tool, measure, you'll be able to easily measure between centers, no problem. Even with inactive components, you can see that it measures between center points. And finally, I want to show you again, keep in mind that all these components are inactive. We can use assembly configurations easily to identify and isolate certain areas within assembly. And let's see how we can place assembly relationships on these components. So I'm going to bring this just to make sure we have this component inactive. I can bring the copy of this component, and I can inactivate it, and we can get rid of the original one. So let's see how we can place using assembly command, how we can create assembly relationship. Quite easily we can define faces on inactive components and place those assembly relationships without any problems. So this is huge convenience, huge boost in this workflow, because now you don't have to activate parts and assemblies in order to perform all these operations. So next step, I want to talk about in general productivity boost when it comes to working with humongous or large assemblies. I'm going to show you how we can open large assembly, and I intentionally place this assembly statistics for this assembly I'm about to open. just to show you that we're dealing with over 4,000 components in that assembly. And I actually placed timer, and we will see how long it will take to open this assembly with over 4,000 parts assembly, how long it will take to open it in a regular way in SoundEdge. So when I say in a regular way, I mean not using any large assembly functionality. We just open this as it was saved. So whatever components were enabled or active, they would be active. Whatever components were inactive, they would be inactive. And of course, I speed it up so we're not sitting waiting here for 2 minutes. But you'll see that when we come to the end of this short video, you'll see that the whole process took us about almost 2 minutes, minute 57 seconds. So let's take a look at a different approach. I can take the same assembly, except now I'm going to utilize this functionality for large assemblies. So I can go and say, instead of opening this assembly as saved, I want to open in a large assembly mode. What it means that by default, that particular setting will inactivate all the components. But I'm going to go even further. I'm going to say, hide all the components, okay? And when I open this assembly, you'll see that it goes almost instantaneously. So there is pretty much no waiting time. I just open that assembly, and I can just show the components I want to work with, and I'm going to start working on this assembly. So this is one area where this new functionality comes really handy, because I don't have to activate parts and wait till it happens. I can work with inactive parts, and you can see if I expand this assembly, all of them are inactive. And yet, let's say I want to modify this part. I'm going to isolate it on the screen. And again, remember, all parts are active. One thing you need to be aware, if I want to make, let's say, synchronous change on this part, and let's say I want to move this hole a little bit. As soon as I start performing any operations of this magnitude, immediately part would be, let's say I want to move it 10 millimeters. Immediately part will be automatically activated for me. Of course, all the instances of that part are going to be active. So you can see for yourself that tremendous boost in productivity, where you're not waiting till you open assembly, you're not dealing with the extensive loads on your system, memory, because you don't have to. And that's the whole idea behind this inactive, working with inactive parts. So let's keep moving. Next topic I want to talk about is copy paste. This is also a very important area, because we want to make sure that when we copy paste, we're not dealing with extra burden of dealing with assembly relationships. So now it's all available as part of SoundEdge 2021. So what happens when you copy and paste multiple parts? The assembly relationships are preserved, and within the parts and between the parts, I should say. So it retains internal relationships between components. You're not wasting time recreating them. It allows for internal, external, and learned relationships. We're going to talk about this. Same approach is taken with subassemblies. So if you copy and paste subassemblies, also there are a couple different relationships. There are relationships between components inside of that subassembly, which we call internal, and also we have external relationships where assembly, how it fits in your overall assembly. So all this information is available now and preserved when you place in copy in your assembly. So let's do that. Let's open couple assemblies. And I'm going to open a couple assemblies at the same time. So one assembly we're going to use to copy components from, and second assembly we're going to use to place components in. And we'll see how SoundEdge 2021 handles this transition. I can tell you right away that productivity is tremendously improved in this area. So once we open assembly, we can easily use different tools, of course, because right now I'm opening them as saved. I'm not doing any specific options when I open assemblies. And now I'm ready to copy and paste components. So we're going to copy components from this subassembly, and we're going to place them in this more, I should say, more elaborate assembly, we can easily identify components we're interested in. Let's say we don't want to see that extra set of components that are irrelevant. So we're going to go back to the source assembly. And please note that this productivity really helps us to select not only single parts, but we can combine sub-assemblies and single parts in one single operation. Then I do Control-C for copy, and I go back to my target assembly. And once I do Control-V, you'll see that immediately we're presented with a dialog box that shows us a set of relationships that we have to go through. Right now, we're looking at learned relationships, meaning those relationships between single components. They are not within subassembly. They're just between the screws and this cover. And you can see I can easily go and identify all of they get highlighted, all this relationship between different learned relationship between components. And by the way, you can always turn off this screen or turn it on back. Now, if I look at external relationships, those are between subassemblies and our target components. And you can see you present it almost like with a capture fit type of functionality. All I have to do is just satisfy different conditions. Let's say I need to mate to the top face. If you want, you can skip. Let's say you don't want to see this particular axial alignment. I can just uncheck and I only face in placement with this additional axial alignment. And then we move on to additional components to be placed. And you can see that screws are not presented. Any relationships are not under the screws because system understands that those internal relationships between those two components. And what's left to do is just to satisfy these conditions for single components and place it appropriately in our assembly. Once we satisfied all the relationships, system conveniently and efficiently places the subassembly and single components. And if we take a look at the relationships, we can see that all of them are preserved. What we call internal, or I should say learned relationships, the ones that were captured between, let's say, screw and that cover. And since I have this set of components on my clipboard, I can do again Control-V for paste. And another option I'd like to point out is what we call manual assemble. If you don't want to deal with all this relationship that come with the subassembly, a set of components, you can say, no, I want to manually assemble. And this dialog goes away, and you can start placing regular, using regular relationships like we normally do in assembly. So hopefully you can see how efficient new functionality is and what it brings to the table when it copying components within the same assembly or bringing from outside. And finally, the next third topic I wanted to discuss, internal components. This is again another functionality that comes with SolidEdge 2021, and this topic is important because I believe it's by request from many customers, because when you open assembly, sometimes when I talk about data that you bring from other systems, whether it's Parasolid or STEP, or you use any kind of CAD tool outside of SolidEdge, and you bring that data inside of SolidEdge, previously, before 2021, SolidEdge 2021, we would have to create, once you save the assembly, we would have to create components on the hard drive. It takes time, it takes space, but what if you want to avoid that? Not a problem. Right now, in SolidEdge 2021, you can see the differences on your screens. So internal references are preserved to the internal components inside of assembly, and when you save it to hard drive, only assembly gets saved without creating any outside external components. As with previous functionality before SolidEdge 2021, system would create all those components on the hard drive. Again, it takes time, it takes space, and the convenience is that later, if you decide to have normal standard SolidEdge components, you can publish that those internal components and create real components on the hard drive. So this is dialog box displays how you would use that. It's available for external type of data types, Parasolid, Stabbed, IFC, JT. It's very convenient to use any supplier data. And all you have to do just enable that create internal components while you in that dialog box. So here's an example also. It speeds up not only saving that assembly, but also it speeds up opening that assembly. Here's an example. While opening this assembly as a Parasolid inside Edge, when you create external file creation, create external files, it takes about 28 seconds on 397 files. And when you choose internal components creation, it takes 6 seconds. And as I mentioned earlier, of course, you can save as many times as you want and have all the components preserved inside of your assembly. But finally, when you're ready to populate a hard drive or whatever data management system you have, you can easily do that with publishing. And you have templates available for parts, sheet metal, as sub-assemblies, and it's a very convenient way of improving productivity when it comes to dealing with data coming from other systems. And by the way, you're not forced to use only this type of components, internal components. You can combine them with the standard components, sheet metal parts, regular model parts, and they live together under the same assembly structure. And what's important also that to understand that even with internal components, when you don't create real components on the hard drive, you will still have access to a lot of functionalities available. For instance, if you can apply assembly relationships to internal components. Here's an example of how this mechanism works if you actually applied relationships and created some kind of animation. Also, in a draft environment, a system will be able to create a bill of materials with balloons and parts list. There are some, here's the functionality that right now is supported. And again, I'm not going to read through that, but you can see a lot of functionalities available with internal components. But of course, there is always room for improvement, and there are some limitations. In particular, you cannot create new component while you're dealing with internal components. You cannot do transfer, disperse different components from a sub-assembly to assembly. You cannot do simulation on those components, internal components, and so on. But it's going to be, in the future, we'll see more and more improvements in that area. So right now, I'm going to show you the example how it will work. I have this Parasolid, and as I mentioned earlier during PowerPoint, so all you have to do just under options, enable this create internal components option. Once you enable this, you can just simply open, and then it goes like a normal process using assembly template, and it will immediately open that assembly and create internal components. And you can see the difference between structures. So it displayed with this kind of glyphs next to components. And one thing I'd like to mention that if I save this assembly, like I showed you before, once I save this assembly, if I go and look at the hard drive, you can see that I have only assembly part and the configuration file. That's it. No components are created on the hard drive. And yet we'll be able to deal with a lot of functionality that I listed on that PowerPoint slide. So for instance, I want to take a look at Assembly Relationship Manager and get rid of some relationships. So I want to preserve a ground relationship maybe for this component, but I can get rid of extra relationships. I don't care to have this ground. And I have only base frame left grounded. And then I can rely on Assembly Relationship Assistant, where I can select all the components and process them in terms of mate, planar alignment. You know, you're familiar with this tool. Once I process, you can see that all on this internal components, I can still use all the assembly relationships and create them in no time. So you can see if I click on any component, we'll see relationships are automatically created on these internal components. And the reason why I want to show you this, because let's say for this subassembly, I want to suppress for a minute this particular alignment. And the reason I want to suppress because I want to show you that mechanism works. So when I start dragging this component, you can see that all assembly relationships are properly honored and it moves as it should with those cylinders available. Okay, now we are switching back to Kevin and he will continue showing you the rest of this functionality we're talking about.
All right. So yeah, thanks again, Ilya. And just for those who are attending today and or maybe watching after the fact, we're going to wrap up today. I'm going to talk a little bit about some of the enhancements in Solid Edge 2021 within the frames environment. If you've been around for a long time or even if you haven't, Solid Edge, one of its strengths in the mechanical assembly space has been its ability and how it can create frame structures. And we're going to go through some additional enhancements in terms of round tubing and how we work with round tubing and specifically more with butt end conditions. I'll talk a little bit about some weld gap options, end caps, and then also how we report whenever you have to make cuts on a frame structure, how we report that. So real quickly, I'm just going to go through just a couple of slides and then I'll show the majority of this live within the product itself. But if you look over here on the right-hand side of the screen, obviously when you create frame structures, there's many different ways that you can butt the components together, whether you have a mitered condition or whether you're butting one frame up to another. Or same thing with round tubing, and then if you look down here at the bottom, you may have specific options where you might cope components together, and there are many different ways that we can now include weld gaps, and this is essentially for better accuracy when we're creating the cut list for those frames, and I'll show you all of this here in just a few minutes. The second area we're going to talk a little bit about in terms of frame enhancements is the ability to have end caps automatically added to your frame structure. You'll see here there are options for setting, what your materials are, and then also how do we create the end caps. My favorite, which I'll show you in the demonstration, is just utilizing the cross-section of the frame that the end cap's going to go on, but there are some other options that you can see there in the dialog box. And then from a reporting perspective, the end caps automatically go along for the ride in your bill of materials. So it'll count them up, it'll specify what their material is, how many there are, as it would any other component within your assembly. So I'll show you the end cap tool as well. And then the last thing in terms of frame enhancements that we'll talk about is just how we report the end conditions of frames and that you can see here listed in this image. So as we talked about, sometimes you have just a standard miter corner. Sometimes you have special trim conditions where maybe you have a component that's butted up against something maybe at a specific angle, or maybe it's also butted up secondarily to another frame member that is straight across. And you might have specific trim cases, and we have some new tools as we report those within your bill of materials or your cut list on the end and side conditions of those frame members. And we have some options there that we'll talk about and how you can specify each of those angles very, very quickly. So with that, I think this will make sense if you see it more visually. We'll talk a little bit about some of the tools here live within this particular assembly. I'm going to turn off all of the components that aren't relative. So let's just look specifically at the frame components. And as you guys know, as I mentioned, Solid Edge does a really good job of automating this process, has a lot of power in creating these types of structures. Let me go ahead and turn off the perspective for a second. So again, you can see the base frame here. We've got some mitered corners. We have some other tools or some other frame components that are listed over here on the left-hand side. For example, these frames that stick up a little bit that are holding the tanks. You can see those are maybe a little bit smaller in cross-section. But the first thing I want to talk about, which may not seem like a really big deal, but just to talk about if you've ever played with the frame tool and you've worked with circular tubing or circular cross sections, we've made some enhancements in how Solid Edge handles that within the butt condition of how those things are butted up relative to each other. I'll also draw your attention to, if you're not familiar with Solid Edge 2021, we have some new tools here. You'll notice that I have some commands listed underneath my main toolbar. So for example, Solid Edge learning how I use the tool. So it basically gives me options that it thinks that I may want to go through and utilize. So for example, as I've played with this particular assembly or been working in it, Solid Edge has learned that I've been utilizing the frame tool, so it automatically places that here. And not to go into a lot of depth on how this works, but you'll notice that this automatically changes based on what I'm doing. So we'll go into the frame environment, and then I'll go and select that I want to create a frame utilizing some of these sketches. Here I'm going to change the conditions or the corner treatments to the butt option. And then I'm going to go ahead and also utilize round tubing. So I'm just going to select, in this case, these elements here, and we'll accept that. And as you might expect, when we have the butt end condition, those cross sections are just butted up to each other, as you might expect them to be. In previous releases of Solid Edge, this worked sometimes, and then there were some times where the conditions, specifically here in corners, may have shown as more of a coping than it would actually butting up to the bottom, in this case, of the tube. So we've made this some conditions here, some enhancements on how it handles round tubing. And then just as typical, if you needed to make changes to this, and as an example, I may want these vertical frame members to be the long end and just have the horizontal frame butted up as it's shown here. So you can always go back through and change that. When I hit apply, you'll see that it changes that, and those butt conditions are as we would expect. Now, the other thing I want to talk a little bit about too, a new option that's added as you're creating these members, is we have a new option here called Set Weld Gap Value. So right now, these members are butted right up to it, and in some conditions, that may be how some companies weld those frame structures together. Some companies may decide that they need to have a little bit of a gap in there, to make room for weld material. So we can go through now and check this box and specify what that weld gap is. And if you just take a look here at the conditions at the ends, if I apply that, you'll see that it automatically applies globally for the entire frame structure for that specific frame member. It applies those weld gaps automatically for us. So right now we have just a straight butt condition, but if I also decided to turn on coping, which is not a new function, this has been around, but that weld gap also applies even if I turn on coping. So if we zoom in here a little bit, you'll see that that weld gap is there as well. Now that weld gap can be changed, and I'll go ahead and exaggerate this a little bit just so we can see that push out even further. Where this also applies as well, I'll go ahead and turn that back to 5mm weld gap, is after I have finished completing the frame members there with those conditions, I also have the ability to come in after the fact, and I can modify specific members of that frame. So let's say, for example, I want to select this horizontal member down here. Whenever you select a member of a frame, you get these automatic editing tools. So I can edit the entire definition or do something with the cross section, or specifically when I go to the end conditions, and again, this specific tool is not new, but if I go to the end conditions, now we've added the ability to modify the weld gaps for specific members while leaving the rest as the default. So for this frame member down here, if I wanted to modify just that one, I have the ability to do that while leaving the other members that same value. In addition to that is if you do override the default value and make a modification, there's also an option here called clear the override, which will take that back to its original condition. And then it just gives you feedback here that, hey, I've gone ahead and overridden the two ends that you had modified previously. So it gives you some feedback in that regard. So again, the first thing was just some improvements here within the working with round tubing or round frame members. And again, if we talk about this base frame here, this base frame has a number of conditions from miters to butt conditions for these vertical posts. Again, if I wanted to go through and make a modification to all of those members simultaneously with that weld gap, you can always go back and just turn that on after the fact. And when you hit apply, you'll see in just a matter of seconds, it'll go around the entire base frame at all of the joints there and add that weld gap in automatically. So just wanted to show how you can go back and either do that on creation or go back and make modifications after the fact. I'm going to turn the weld gap option off for a minute, and then I'm also going to change this base frame from mitered corners here on the top and the bottom. I'm going to change those to where those conditions, the frames are open on the ends. So we'll apply that. And you can see here how we went ahead and opened up on the four corners there, these frame members. So they're now open on each of the four corners. I'm going to do the same thing to the tank frame. So if I click on that and make a modification to that, go into the options, I'm going to change those to a butt condition from a miter as well. And we'll apply that. This time I'm going to have those opened up in a different direction than the ones from the base frame. So as you see here, again, the base frames are opened here in this direction. The tank frames are open here in this direction. And then the frame that we worked on earlier, it's opened up here on the top. So the reason I did this is just to talk a little bit about this new tool called Frame End Caps. So Frame End Caps allows me, as I mentioned, I can go ahead and place end caps on any open frame member. I'm going to utilize this option here, utilizing the frame cross section. If you don't like that, you can go ahead and choose some of these other options here. And I'm not going to go into a ton of detail, but just to show that I can go through and I can easily select any open cross section. And I'm going to do that for all of the ones for the base frame. We'll do the same thing for the ones in the tank. Now remember, these tank opened ends are different size. They're also in a different direction. There's 8 of these total as well. And then I'm going to do also the circular tubes. So these are all different directions, all different sizes and cross sections. And when I hit apply, you'll notice that Solid Edge will automatically go through and apply end caps to all of those members at the same time. So a really nice handy tool that's available when you have opened frame members. I'm sure if you've ever bought a piece of furniture that has structural steel members. I have a desk that I'm sitting at right now that has those types of end caps in them right now. And then just from a reporting perspective, if I expand the base frame as an example, you'll see that the end caps are listed here. And those will be automatically included within the bill of materials. And it would be the same here for the other structures. So it places the end caps within the same structure as the frame that they reside in. So the tank frame and then the last frame that we created here, those are listed there as well. All right, we're going to switch gears a little bit as well. I'm going to change the display. We're going to look at some frame structures down here. I'm going to turn on a couple of other frames. And I want to just draw your attention here on how we can calculate now some of the conditions when we have to create cuts at the end of a frame structure. So if we just look closely at this particular frame structure. We have some horizontal frame members here. And then if I look at the sketch for how these angled frames were created, you can see that these two frames are at the same angle. So in reality, these two members are identical, and then these two angled members are identical, okay? So let's go over to the draft of this. And what you're going to notice here within the draft that it's currently out of date. So right now I have, you know, 4 frame options or 4 frame members. When I update my views, however, you'll notice how it's going to add some of the end caps here that were added with the frame. So again, just to reiterate that some of the end caps for the entire structure, again, this particular bill of materials is of the entire assembly, and it's just added those end caps here. I can go through and make changes, but when I update those, you'll see that those end caps are included within the bill of materials. Specifically though, if we look at some of the members themselves, let's look here at frame member number 7, which is this angled component here. And you can see if we hit the quantity as shown in the balloon, there's 2 of those which represent these 2 angles. And you'll notice here if we look at miter cut 1, again this is referencing the angle displayed here. So we'll go through and just throw that out there. And then you'll notice here, these are some new options called end angle for 1, and then we also have end angle 2, which would be the opposite end. So let me go through the options or the properties of this bill of materials. You'll notice under the columns tab, these are what we're defining here. And actually this, you'll see here we have end angle 1, the end face, and then end angle 1, the side face. And we can calculate what the angles of both the end and side faces are on each end of the frame member. So there's, and you also notice as well under the options menu for unique pipe frame and pipe uniqueness, because this also works on piping. If you've used this tool previously, this option here called end angle used to be called miter. So we've now added some new enhancements for the saw and the cut angle. So that's where these new options are coming into play. Specifically, this 10 degrees here for the end angle, just to show here as well. If I come in, and I'll just do just a quick visual here. If I create just some line elements at the end of the frame member, we'll come and make those perpendicular here. Essentially, this angle is what you're seeing here. And I'll just trim this away. So essentially this cut angle, in order to get this mapped to the other frame member, that's where this 10 degrees is coming from. Okay. Now I'm going to go ahead and make a change to this just to show how this updates. So if I go back to the frame member here, and we'll make a modification to this sketch. We'll go ahead and keep this in line vertically. But what I'm going to do is I'm just going to randomly make a change and put this at an angle. And obviously by changing that sketch, it's going to update the frame structure. Now the edit that I just made is obviously now this is now a new unique frame member, and now these 2 frame members are now different. So if I come in at this point and now update my views, obviously it's going to add additional members here to the bill of materials. And then it's also going to make modifications to the ends. So obviously this angle did not change, but this end and side angle did change. So now this part is referring to is frame member number 9. And you can see that we still have 80 and 10 on the one end, but then we've got new values here for the end up here. So again, just wanted to talk a little bit about how when you are making modifications or changes or need to go through and calculate or report what those angles are, there's some new options listed here within both the draft parts list as well as reports. Here, the last topic we're going to talk about before we end today's session, I want to talk a little bit about some new tools that we have for supplier catalog integration. So, you know, we've had tools in the past where we could go manually out and find different supplier components, but now with this new 3D Find It integration within the assembly environment, within Solid Edge, it's going to make this process much easier. So there's many different ways that we can now access supplier components, and I'm going to show you some different ways to do this right here from within Solid Edge. So let's go ahead and open up this new assembly. What you're going to notice here is this new option called 3D Find It is available to you within the interface. It's available under the Insert menu. You can also access it from some other areas as well. But this gives you the ability to find these components. I'm going to go ahead and close out some of these other assemblies just to show some of the other options that are available as we're finding these supplier components. But this allows us to go through and find different supplier components. So you can go through and search for things. You can go through and find the supplier integration within different areas of the product. And you'll see here that there are options that finds it within our search tool, but you can go through and insert components from within the application. So when I go there, and I guess the thing to point out too, you'll notice that I do have an account, so it's very easy to sign up for an account. Just do that and sign in. But once you go to that tool within Solid Edge, there's many different ways that you can search for those supplier components. So if you'll notice here, the icons within the search dialog, these are all replicated down here with the description. So you can search for supplier catalog components via catalog or classification. There are geometric searches where you can pull up a sample 3D model and it'll do searches related on the geometry of that geometric search. You can do sketches and it'll find components that have elements related to something that you sketch. You can search by color. You can search by function. There are some other options here, which we're not going to go through all of these. I'll show you maybe 2 or 3 different options. But then there's also the general text search. So let's start with that, which is the most common. And again, if I type in any word here, let's just type in cable gland, you'll notice that it'll go out and it'll search for supplier components that have that within the text. And you'll notice over here on the left-hand side, we have access to a number of different supplier catalogs, and you can go through and filter to specific ones. Or if you want to look through all of those, you can specifically look through all the catalogs. But you can go through and you can do multi-search terms. So maybe I want to also, put the ISO term there as well, and it'll go through and filter those out even further. So you can go through and look through some of these. You can go through and select one specifically. If I select this one as an example, you'll notice that it gives us access to a viewer. That viewer also gives you common viewer tools like doing dynamic sectioning through the model. If you want to get an idea of how large this part is, you can turn on a grid and get an idea of how big this part might be. You'll also notice over here on the left-hand side, it allows you to configure some of the different properties or values or variables related to this part. Maybe I'm looking for a specific chord range as an example. So I can click on that parameter and commit that, and it'll go out and find that specific one. And again, if I turn on my measuring grid, this part's a little bit bigger than the one that we looked at previously. Now, you may be happy with the first component that you find, and that's fine. You can also look at other elements of the part that you find. If you want to look at, a typical drawing with a bill of materials, or if you just want to look at, a specific view in 2D, you have many different options for how you might want to look at this particular part that you find. So both from a 2D and a 3D perspective. You can also go out and search for similar parts related to the part that you're currently on. So if I click on similar parts, you can go through and change the slider bar for your percentage of how similar the parts are, and is it based on your size. So when I click search, in this case, it'll go out and find other parts that are similar to the one that I just selected. If I go through and select one of these, maybe in this case, we'll look at just maybe one here from Sealcon, and maybe let's choose this one here. What's nice about this too is you can also go through and compare the two models. So I can come in and maybe specify some different values here. Let's maybe make sure we're comparing the same sizes, so we can go through and change that parameter to the same parameter from before. But there's an option here also to compare the two that we found. And those will pull up those parts side by side here, and those do look very similar to each other. And then you can also populate those on top to make sure that those are, essentially the same size component. And then go through from here, which one do you want to access by comparing some of the different properties. Once you've determined which one you want to utilize, you can either download that file somewhere to disk on your hard drive, or if you just want to send it directly to the assembly that you're working in, you can go ahead and say send that to Solid Edge 2021, and then that will come into the Solid Edge environment, and then you can place that component right into your assembly. So it's going to go ahead and download that and place it here in just a matter of seconds. And as that finishes downloading here, you see that it plops it right here into my assembly, and then I can just utilize, my standard assembly relationships to populate that, and we'll flip that around and then just populate the center here where it belongs. So very easy to utilize and find different components. And again, you can see that that is now, because I've used that within that assembly, that is now listed here for easy access. I'm going to go back to the 3D Find It just to show you a couple of other ways that you can search for components. So we talked about just a typical text search. You can also do a geometric search. If you have a component, maybe you downloaded it from GrabCAD, or maybe a customer or a vendor sent you a 3D model, doesn't have any intelligence or associativity to anything, but you have a sample file and you want to look for something that's similar to it. I can go ahead and select a file. Now currently, just to let you know, currently this is specific to neutral files. So if I wanted to come in and look for a sample Solid Edge file, native Solid Edge files are going to come later, but currently we can have it search for neutral files. So let's go into a folder where maybe I have some different files that I want to do a search on. So in this case, I'm doing a gland, a step file. So I'll open up that step file right here within the 3D Find It interface, and it'll import or bring that part in, and then I can say search for parts that look like this. And when I search for that, it'll go out, as you saw it do before, it'll go out and find components that are like this from different vendors. And I can search all catalogs, or I can search specific ones. And just as you saw me do before, I can go ahead and select a specific one, key in different parameters, and then bring that into my assembly. So that's based off of a geometric search. And again, as you saw me do before, you can also key in multiple search terms. So in this case, I'm doing a text search along with the geometric search to more filter out specific components that I want to look for. Okay, and because we're running a little bit short on time, I'm not going to go ahead and place one of these, but I did want to show you one more option here, which is the sketch search. So if I go to a sketch search, what I want to do, if I go back here to Solid Edge, if I go back here to my assembly, is I want to find a handle. So I'm just going to do just a basic sketch of a handle, nothing real complicated, but I want Solid Edge now to search for this sketch. And it'll go out there and it'll look for different parts that maybe have that shape. And I really don't want a table necessarily, but let me also go ahead and add in a search term of handle. And let's see if it can filter my sketch along with the term handle. And now we're getting a little bit closer, as you can see from the elements up here on the top row. This is more what I'm searching for. And then again, if you want to filter that even further, if you know a specific term or a specific value that you're looking for, you'll see it'll filter that out even further. So this is more what I'm looking for, maybe this particular handle. And then I know that my hole spacings in my assembly are 6 inches apart versus 8, so I can go ahead and key that in. And then, as you saw me do before, I can send this specific handle very quickly from the supplier catalog directly to my solid edge assembly. And this will download the model right here into Solid Edge. And then I have the ability at this point to go ahead and access that and drag that in from the library and then place this handle in very quickly. So we'll just do a quick axial alignment. We'll do the same thing here. And then here in just a matter of seconds, I've grabbed my supplier part and placed that here into the assembly. So again, as I mentioned, the 3D Find It tool, it is within the Solid Edge environment. So it's listed under the Insert Component option. It's also found here under the Applications menu. You'll see that listed there. And then whenever you do download those components, within the file locations area of the Solid Edge options, you can specify specifically any component that you find from the supplier catalog. Where is it going to store that file on your computer? Where in the system do you want to place those and keep those files? So that's another option. The main thing I want to talk about too, which is in my opinion is great, is the fact that this supplier catalog integration, the 3D Find It, it's included with Classic and Premium. So I would say the majority of your customers today, when they upgrade to 2021, are going to have this capability, and they're going to find a lot of value and a lot of benefit for this particular application.